Hello folks, we come to the part 4 video of this miscellaneous exercise and we are taking up now the problem number 10. The problem number 10 says that there is a GP and there are 3 terms in the GP whose sum is 56 when you happen to subtract 1, 7 and 21, then it gets converted into an AP. We'll quickly check what they ask us to find. Then in that case, we are supposed to find the numbers. We have got to find what these numbers are. So let's quickly go about doing it. Maybe because it's a GP, let maybe AR squared be the terms. So this is the sum. So A plus AR squared is 56 in the first case. Also A minus 1, AR minus 7 and AR squared minus 21 is an AP, or rather 2 times. That's how we write. If ABC is in an AP, then 2B equal to A plus C. So 2 times AR minus 7 is A minus 1 plus AR squared minus 21. Let's quickly work this out. This is 2AR minus 14 is equal to A minus 1 plus AR squared minus 21. Let's have everything on one side. AR squared, then plus 2AR, then we can have AR squared, so minus 2AR, kind of taking it on the other side, and then minus 2AR and all the other terms. So you have minus 22, and if this comes there, it is minus 22 plus 14, so that's minus 8. So that's sorted out. This is gone, this is gone, this is gone. Then you want this, these both are gone, and then you want the plus 8 equal to 0. This is a term that you're getting here, and here you have A into 1 plus R squared equal to 56. So this could be probably A into 1 plus R squared equal to 56. Right, so once we get across doing this, it's like maybe we could have it like this: A into R squared minus 2R plus 1 equal to 8 if we want. The 8 goes on the other side, the other terms we club together, and A can also be written from here as 56 by 1 plus R squared. Let's take it like that. This A will replace by 56 by 1 plus R squared, and here this, if you want, we can write it as R minus 1 the whole square. I hope it's clear. From here we have got A as this expression, and here we have got this expression as A into something. That A from there we are replacing so that we get everything in terms of R, and we are able to find out at least R or A or whatever. So let's see now what happens. So this is like 56 times, you can have 8 7s are 56, so maybe 7 times R minus 1 the whole square. This can go there, so it's R squared plus R plus 1, and then this is 7R squared minus 14R plus 7, and this is R squared plus R plus 1. Let's have it solved. 6R squared, then minus 15R, then plus 6 equal to 0. 3 common factor, so 2R squared minus 5R plus 2. 2 2s are 4, so 2R squared minus 4R. Right, so 2R times R minus 2 minus 1 times R minus 2, and so on. So R minus 2 and 2R minus 1 gives you your R value as 2.5. Now they ask us the terms. Okay, so our A value from here will be for both these cases. For R as 2, it will be, let's work it out. If R is 2, it is 56 by 1 plus 2 plus 4. So that is 6 plus 1, 7, it will be 8. And for R equal to half, it will be 1 plus half plus 1 by 4. So when we equate, it is into 4 into 4 into 2 into 2, and that 4 can go up. So you will have 4 plus 2, 6 and 7. So 56 into 4 by 7, which is 8. So that way it will become 32. So you have this. Then you can get the terms. Therefore, the numbers or the terms are, first term is a. So it's 8 for the first one. Next one it is 16. Then it is 16 into 2, 32. And the other term will be starting with 32. Then 32 by half, that will be 16. And that by half is 8. So these are the terms. Next we come to the 11th problem, where they say that there are even number of terms, and when we sum up these even number of terms, the sum comes to 5 times the sum of terms that is obtained by adding those things which are there at the odd places, and this is a GP. So from the given, if A and R is as usual, from the given it is like A into R raised to 2n minus 1 by R minus 1, and this is like 5 times A1 plus A3 and so on, A to n minus 1. Let's check how this comes. First one is A, then it is AR squared, then it will be AR, fifth term, so AR raised to 4, then this will be AR raised to 2n minus 2. So if we want, we could take the A out, and then we would get R squared, R raised to 4, and so on, R raised to 2 times n minus 1. We carefully observe this GP. What kind of GP? GP with A as 1, common ratio as R squared. So whenever if you want to find the A R raised to n minus 1 by R minus 1, this formula you will have to obey. And here you have R raised to 2n minus 1 by R minus 1. A, let's cancel. Now R raised to 2n minus 1 by R minus 1, we'll use the sum formula here. A is 1, and the common ratio for us is R squared. And there are how many terms? There are n terms, because till here there is n minus 1 and this one term. So R raised to 2n minus 1 by R squared minus 1, because the common ratio is R squared here. That can allow it to get cut. And actually this R, that means it's R minus 1 into R plus 1 or not? A good old formula. A squared minus B squared is A minus B into A plus 1. By that you can have this also cut. So what are we left with? 1 over here, 5 over here, and R plus 1 over here. The R plus 1 can quickly go there, 5. R becomes 5 minus 1, 4. This is our problem number 11, and I will make a quick checking. Yes, R is 4. The common ratio is 4. So just putting up the values like that. Then we have the 12th problem. It says that there are 4 terms in an AP, and the first 4 terms they add up to 56, and the last 4 terms they add up to 112. You have to find out what is n, and they tell you the first term is 11. They are very kind. They have given you the first term also as 11. So quite a lot of data. So actually it could be like this given, right? First is 11, then 11 plus t, 4 terms, 11 plus 2d, then 11 plus 3d. All this together is making it 56. So 11 plus 11, 44, plus 3d plus 3d, 60 is 56. So how much? 60 is equal to 56 minus 44. That means 2 and 4, 12. So d is 2. Huge data. Last 4 terms are adding up to 112. So also, if the last term is L, then we have L plus L minus d plus L minus 2d plus L minus 3d. We can tell it like that also. We'll go behind, instead of going like that, right? So that will come to maybe 112, they say. So 4L, and then minus 60 is equal to 112. Now 60 is a known factor 12. Yeah, because d was 2. So if it goes there, it will become 124. How about L? 124 by 4, that is 31. So the last term is 31, but that's not what they have asked us. They have asked us what is n. Okay, therefore in that AP, A plus n minus 1d will become 31, where A for us is 11. N we don't know, which term it is we don't know. So when we subtract 2 times n minus 1, 31 minus 1, 20, 11. 31 minus 11, it's 20. So n minus 1 is 20 divided by 2, which is 10. N minus 1 is 10. So what is n? 7. When the 1 goes on the other side, it becomes 11. Quick checking? Yes. Right. And we should also once check what they ask us. Find the number of terms. Yeah, the number of terms are 11. That's our problem number 12. The remaining problems we are taking it in the new video. Thank you.